Knox Game Design, March 2021. Sorting.
Welcome everyone to Knox Game Design for March 2021. So this month the topic is going to be sorting. I just want to mention I had a little bit of a technical issue last month. I used the new studio layout in OBS and I didn't realize that the video that was being captured wasn't the live video. You actually have to push that over. But fortunately it still did capture my desktop. So the talk on mazes, I was able to salvage it. It just doesn't have a picture of me on there. So let's go ahead and get started. So yeah, this month is going to be about sorting. Just a quick overview, what I'll be talking about. So I feel like sometimes I don't give a good explanation at the beginning of what I'm going to be talking about. So yeah, this is going to be the basic. So in order to sort items, you need to know how to compare items. So I'm going to start out talking a little bit about comparing. And then I'm going to talk about the different algorithms. Algorithm is just basically a set of steps on how to sort a group or collection of items. And the runtime is actually how fast those will run as you increase the number of items. And then I'm going to go over multiple implementations. I actually worked quite a long time on this presentation, probably a lot more than a lot of my other presentations. So I did implementations in Unity, and for each of these implementations, I did a sorting of integers, a sorting of character strings, and a sorting of objects. Because each one of those is usually a little bit different. So I did Unity, C#, GameMaker and the GML language, Godot with GDScript, Unreal Engine with C++, and Pico 8 with Lua. So why is sorting important? So if you play a lot of games, you'll probably see some sort of sorting in those games, especially in games like RPGs where you have a lot of items with different attributes like cost or attack damage or defense. I have some examples here, like in World of Warcraft. You have the auction house, so it's very beneficial to be able to sort those items in the auction house. You can sort by which ones are nearing expiration. You can sort by cost. You can sort by the seller. So things like cost and it is the actual integer value. A user's name, sometimes those are represented by IDs, but the actual character strings, that's a string of characters, so that's a little bit different than comparing integers. And other examples are like a racing game where you have multiple racers and they all have different lap times and overall times. You need to sort those times. Games like Final Fantasy usually have an inventory screen, and then you can go in there and sort those by item type, or the number of items, or the rarity of the items, things like that. So I'm going to talk a little bit about how to actually compare items. So if we're comparing items by integer value, and integer is just a different name for like a whole number. Integers do have limits on the different architectures, but generally you can just think about integers like the whole number. 0, 1, 2, 3, 4... -1, -2. I'm not going to be talking about negative numbers in this, but just any whole number. So comparing two numbers, whether one is greater than or less than, is like that's something that a lot of us learned in elementary school. 2 is greater than 1. 42 is greater than 41. 10 is less than 20. I mean, just basic comparing of integers. So a character is what most of us know as the alphabet. A, B, C, D, E, F, G. Those can be either uppercase or lowercase, but characters can also be symbols, like anything you see on the keyboard, like a asterisk or question mark or a period. So generally in this talk, I'm just going to be talking about sorting generally alphanumeric characters, and not talk about the special characters, but each character is represented by an integer value, and on most systems this can be translated to the ASCII integer value, and ASCII stands for American Standard Code for Information Interchange. I always get that wrong, so don't hold me to that. So what I always memorized when I was a teenager is capital A is 65. If you remember, capital A is 65 and lowercase a is 97, then you can, in your head, derive any other value. Okay, so the way that you derive the value of any character, so if J is the 10th letter, you subtract 1 from that, then add that to 65. So that gives you 74. Or T is the 20th letter, so subtract 1 off that, 19, add that to 65, then you get 84. And you can do the same thing with the lowercase letters. And also, the numbers also have an ASCII character value, such as 0 is 48. And there can be tricks in sorting and comparing numeric values. So for instance, if you have a 5 and a 10, if you compare those by the actual character values, a 1 is going to be less than a 5, so that 10 is going to come before your 5 because you're comparing the first each digit slot. So that's when you got to play some tricks and either like pad your 5 with a 0 before or do some other tricks behind the scenes. But we're not going to worry about numbers in our character string conversion. We're not going to worry about numbers for string comparisons in this talk. So a string is basically a collection of characters. So characters A, B, C, D. So a string is a collection, a word, or a sentence divided up by spaces, things like that. And most of those are terminated by a null character value, which is the ASCII value 0. A lot of times you'll see a \0 to represent that null character value, and that's what terminates your string. But a lot of times you don't have to worry about that. You just put it in double quotes or single quotes, and the programming language takes care of that for you. But you got to watch out when you're comparing character strings, kind of like with the numbers. So each language is a little bit different. So in some languages are case sensitive. So if you have apple in all uppercase, and then you have aardvark in all lowercase, then aardvark should come before apple because that second character, the A, is less than a P. But if you look at the ASCII values of the second character, a P, capital P, is going to be 80, and that's going to be less than a lowercase a, which is 97. So that's going to make apple appear before aardvark. So there's some tricks you can do if you want to do a true sort and make that case-sensitive comparison insensitive. You need to convert all those characters to uppercase or convert them to a standard case before you do the comparison. But a lot of other languages, they do case-insensitive comparisons, so then it will automatically take care of putting aardvark before apple. And then in this example, I have cat, dog, elephant, and zebra, and they're all different cases. Some have the initial capital letter, some are all lowercase, and some are all uppercase. So most of the times you want to do a case-insensitive search. And I'm not going to talk about it in this presentation, but some other things that you may want to sort, as I talked earlier, is like time. What you want to do with time is sort by the lowest common, like the lowest common denominator. Like if you got a time in seconds, you want to convert everything to seconds or minutes or milliseconds or whatever. You just want to make sure you take like the hours, the minutes, and seconds, and multiply all those out. Like I think it's minutes times. So if you're converting everything to seconds, you want to multiply your minutes times 60, then add to your seconds, and then multiply your hour by 60 times 60, which is 3,600, and then add that onto your seconds. So you just have one integer value for your entire time value. And also dates. With dates, you want to convert everything to a common starting point in time. So as far as we know, time, I don't know, it could be the starting of time. That's a theological discussion, we'll say, for another time when the time started. But in most computer systems, they have epoch time, which is set to January 1st, 1970. So you convert everything into the number of seconds or milliseconds since January 1st, 1970. So let's talk a little bit about these character values, these ASCII character values. If you have a character, how do you actually convert that into its numeric value. Well, here's some examples. So for C and C++, all you do is cast it. Cast it as an int. Put int in between parentheses. That's what casting does. Converts one data type to another. So pretty simple there. Java, if you have a string, like right here, str, then what you want to do is do stir, then char at, then the position of that character in your string, and then cast that as an int. C#, you can just take that string and put it between square brackets to get the character at that position, then cast it as an int. But in a lot of scripting languages, as you see down here, such as Ruby, Python, the GameMaker, GML, they use what's called ord, which I think stands for ordinal. Could be wrong about that. But for instance, in Ruby, you can do stir your string.ord, and that will return the numeric value of the very first character of that string. Python, you can use ord, and then put your string within parentheses, pass it a parameter, and the same with GameMaker GML. So that's going to return the ASCII character value of that first character. I think to get at a specific position, usually you just have to put it within the square brackets, as I mentioned earlier. So for comparing strings, as I talked about a little bit earlier, most languages, I think a lot of this started out with C. C had strcmp, strcmp, which was in the string.h library in ANSI C. So that took two parameters, two character strings. So character string, as I mentioned earlier, it's like a word or a sentence usually within double quotes. And you'd pass those two parameters to your strcmp function. And then if it was less than 0, then your first string was smaller than the second one. And then if it returned exactly 0, then those two strings are equivalent. In Java, you can take your first string, then do dot, then compare to, then pass in the second string, and it will return the same -1, 0, or 1, whether the first string is smaller or larger than the second string. C# is very similar. You just a little bit similar, but it's a little bit different. Instead of calling this method on your string object, you just use the string class. You do string dot, then compare with the C capitalized, then pass in your two string values. And I believe that also returns a value -1, 0, or 1. In Ruby, they have what's called the spaceship operator. So you just take the first string and you do less than, equal, greater than the second string. And I believe that also returns a -1, 0, or 1. Python, I couldn't find any string comparison, but you can directly compare the two strings using a less than or a greater than symbol. And GameMaker GML is the same thing. You can do first string equals the second string. So before I talk about the sorting algorithms, I want to talk a little bit about this asymptotic notation. If you get into calculus, you'll learn about asymptotes, kind of like how you're taking a derivative as the number increases along a 2D graph on a number line, your values will converge onto a standard line, whether that just be a linear slope, which is a straight line, diagonal line, or like an exponential will go like this, like a parabola, and then you have logarithmic, which kind of goes a little bit down and up, things like that. So for runtimes for algorithms, like we want to know how to actually, like it says here, how to measure how long each of these algorithms take as you increase an infinite number of items to sort. And what I learned was these three different ways to measure that. This big theta, big O, and big omega. These days you'll probably hear a lot about big O, and everybody just ignores big theta and big O. Everybody talks about big O, and they just ignore big theta and big omega. And I have the book right here. Yeah, so this is the book that I used at Georgia Tech for computer theory, and it's actually by Corman, Leeserson, and Revist. I'm not sure if I'm pronouncing that correctly, but I think that's the same Revist that's in the RSA algorithm for cryptography. but it goes into a lot of different sorting algorithms and runtimes and things like that. So one thing I wanted to mention about this, because I think there's some misinformation or some difference in nomenclature about these things. The way I learned it is this isn't a best case or worst case scenario. These are the upper and lower bounds of the asymptotes for the runtime of each of these algorithms. So big theta means is an upper and lower bound. So it's going to like converge directly in between that function as you go into an infinite number of items. Big O is only an asymptotic upper bound. So you might have values below, but you're not going to have any bigger. Now, when the function starts out, when the initial runs of it, you may have some values above or below, but as you go out into infinity, that's a solid upper bound as you go out to infinity. Then big omega is just different, just the opposite. It's the lower bound as you go out into infinity. So some people will say big O is the worst case scenario, but from what I read about sorting algorithms, you can have a big O for the best case scenario, and you can also have a big O for an average case scenario, and you can also have big O for worst case scenarios. So some of these sorting algorithms may have a big O of n for average, then big O of 1, which is just constant, for the best case scenario, which usually means the items are already sorted for you, so there's no processing involved. And also there's something called little o and little omega. I haven't heard much about that, but it's in the book. And that basically means it's not asymptotically tight. So I think that means it will get close, but it never will actually, reach that value. I'm not sure. Everyone out there can research little omega and little o if they choose to. So as I was talking about, here's some of the common run times measured in big theta. You can also use big O. So big O of 1 is constant. The way I think I talked about this in one of the previous talks, but that means like if you have an array and you know exactly where in that array you need to go to get your value, you just go directly there. That's constant time right there. You just go directly there. No search involved. Linear time means you have like an array and you want to find the largest value in that array. So to do that, you have to visit each value in that array, and every time you find a larger value than the current largest one that you've already found, you have to change that. So in order to get that value, you got to go through n values. If your array is n items, you got to go through all n values in that array to find out what the largest value in there is. So that's linear time. Logarithmic time, I don't know how they calculate logarithmic time. I just know that it's greater than linear and it's less than quadratic, and how they actually drive that, that's something everyone can research. A lot of times you'll see n log n, I think, for quick sort runtime. So it's good to have logarithmic beats quadratic, polynomial, and exponential. So quadratic is a special case of polynomial. So that just means it's n squared runtime. Then polynomial means n to a constant value. And then exponential is 2 to the n. So that runtime is just going to shoot off straight up. And typically in computing, you want to get everything at least polynomial time. So I know I've played games, like if you play a game on a really old computer, like a chess game, and it's got to figure out, you play you're moving chess and you're playing against the computer opponent, and then there's this like hang right when it's the computer's turn. You might see a little hourglass there. That's because of this runtime right here. It's taking a really long time to come up with the best answer. So there's ways you can improve that, but right now the best computers, they can't solve exponential problems. A good example is, I might have talked about it last month, is the traveling salesman, kind of like when I was talking about maze generation. And oh, by the way, I want to go ahead and mention, I did get the Mazes for Programmers book by Jameis Buck. So I really like this. It actually goes into a little bit more details than than just the web post. So I definitely recommend if you like the web post. And it's got color pictures. I really like color pictures of the mazes. It's got a whole bunch of different algorithms. I think I'm still on chapter 1, so I'm just now getting into this book. But it goes over like triangle mazes right there, and what is that? Hexagon mazes, and all sorts of different algorithms. So he starts out really slow, just saying, hey, here's how you can actually make a maze on a napkin, how to draw it out. And then he gets into doing examples using code, things like that. So, yeah. So far, I'm really liking the Mazes for Programmers book. So this came like a day after I recorded my talk. So unfortunately, I didn't have it in time for the talk, but I got it now. So here are some of the sorting algorithms. So the first one that I learned was bubble sort. I think I learned this probably in CS 1501 at Georgia Tech, where we were just doing pseudocode. And so bubble sort, you have your array of random values, and then for each value, you're going to compare that one with all of the following values, and then until you find one that, let's see here, yeah, you go all the way through all the values, and it bubbles up all the way to the top until there are only values greater than that one. So then it's going to loop through as many times as the array size is. So it's going to, if you have n number of values in your array, it's going to leap through there, bubbling up each value to the top. And there's actually a cool program. I think I talked about this on an earlier talk as well. It's called The Sound of Sorting. And sometimes you got to play around with this to get it to work the way you want to, because by default it makes a lot of noises and everything. But you can't go in here and like bubble sort and say reset and run. So it's going to actually show you each of these values bubbling up to the top. And you can speed this up a little bit. So that's bubble sort. So insertion sort is another one that is commonly used. So for each item, you're going to go through each index, and at that index, you're going to compare that value with all the preceding values that came before. So it's kind of like opposite of a bubble sort. And then if it's lower than the preceding value, then it's going to switch those two. But if it's not lower, then it's just going to stay in place. So I'm going to bring up insertion sort, reset, run. So you can see there the green bar, each index, and then it's going to compare with the ones before. So heap sort, I'm not going to go into the details of heap sort, but just know that it does run in big O n log n or big theta n log n for average runtime. This is actually in heap sort right here, sort run. So from what I understand, it kind of builds an offside the heap. So that's another thing I didn't mention earlier. Another way to classify sorting algorithms is whether it sorts in place or not in place. So if it sorts in place, then you have your memory allocated for your array, and it's going to start swapping those values in and out in that one chunk of memory. Now, if it doesn't sort in place, it's going to take that, and I think like merge sort here, I think it pulls that off and then stores some of those values off to the side, then adds it back in. So the simplest sort you can do, and I don't even know if there's a name for this, maybe lazy sort. I've done this. Just take each value, find like the lowest value in the array, iterate over the array, then store that off into a new array, and then find the next lowest value and keep deleting those off and add it to a new array. Then copy your new array back into the old array. Now that would be a sort not in place. So I'll just mention some of these. So we looked at merge sort. Here's quick sort, average case, n log n, and then the worst case is big theta n squared. So a lot of these, if you just have a few values, it may be beneficial, but as your data size grows. So some of these, if the data is already in an optimal condition, like they're already nearly sorted and things like that, it will have a lower big N value. And by the way, some of these you may see like big O of 1, but it would actually be like a 3 or a 5. Those constant values are usually dropped off unless it's in the exponent there. So this program has like 5 or 6 different quick sorts with left and right pointers. And also, I already did more sort. So counting sort. So I don't have. Yeah, so this has a lot more. This has many more different algorithms in this than this in my algorithm book. So it's kind of neat just to check out. But yeah, you'll probably never really actually be concerned about which sorting algorithm that you're using. But sometimes it's nice to see if you look in the API documentation. If you look up the sort function for different languages, it'll actually say, hey, it uses a quick sort or heap sort or whatever. So first of all, we're going to start out with Unity, since Unity is usually pretty popular. So I'm going to give an example of how to sort an array of integers. I think sorting a list of integers is similar. You may have to convert your list to an array beforehand. I'm not sure. But the first thing you want to do, first thing that caught me was you have to have using system in your header. Now, if you have using.system, system.collections, using system.generic and all that, it doesn't matter. You got to have using system in your header there. So if you try to do this and you don't have that in your header, then it's not going to. If you don't have that at the top of your file, it's not going to work. So all you do is create your array. You can define an array of ints by using int, then the square brackets, and then the name of your array, then equals, and you use your curly braces, and you put your integer values in there. So I just came up with some random values. This was actually the values that was on my, I think, thermometer and clock at the time and day, and the temperature value. And then I have like 3 GUI text, not GUI text, the UI text fields, so I can display some output. And then what I'm going to do is I'm going to loop over every value in this array and put that as an unsorted value in the first text field. And then I'm going to use, so you got to make sure you do array.sort and then pass in the name of your array. Then put that in parentheses and semicolon. So it's kind of like a class function right there. And then we're going to just loop over that again after it's been sorted, and then put those values in the second column. So you can see the output right here. Put 75, 59, 11, 35, 3, 10, 20, 21, and sorted 3, 10, 11, 35, 59, 75, 20, 21. So I actually have it in Visual Studio right here. So I'll put all this code out online on GitHub, linked from the Knox Game Design website. But I have it set up right here in your start method. You can comment out or uncomment the sort that you want. So the first one is display sorted ints. So here it is, display sorted ints. So this is exactly what I just showed on the slide right there. So you press play, then it shows exactly what was on the slide. A list of unsorted ints, then a list of sorted ints. So that's all there is to it. Pretty easy, right? So the second sort, we're going to sort strings in Unity in C#. So you create a string array very similar to how you create an int array. Just say string, all in lowercase, then square brackets, the name of your string array, the equal sign, then inside curly braces you put the different strings separated by commas. So we're going to use the same output. We're going to print out all those values into the first column, and then do array, the word array with capital A dot sort with capital S, and pass in that array as a parameter. Then we're going to print all of those values out in the second column. So you look right here, it actually does a case insensitive comparison. So here we have orange, banana, grapes, watermelon, lemon, and apple, all different cases, and it actually sorts them based on a case insensitive search. Now, if this was case sensitive, then it would have put like apple with starting with a lowercase a behind banana with capital B. So with the Unity C# array.sort, you don't have to worry about that. And so to see that in the demo, you just come over to the code, and we want to comment out display sorted ints, and then we're going to uncomment out display sorted strings. Save that, and there it is. The two lists, the unsorted list of strings and the sorted list of strings. And the third example that we're going to do is sorting objects. So objects are a little bit different. So it's object-oriented programming. So it's kind of like a structure where you have an object where you have a data structure that contains multiple different values, which can be integers or strings or floats. And typically objects also have methods as well. So that's what makes an object or a class different than just a regular structure. But yeah, so I got this example class that I made that you might see like in an RPG, which is a weapon. And I'm going to use the same example through all the different game development environments. So the weapon in this case is going to be very simple. It's going to have a name. It's going to have a cost, like you're buying it in the shop. How much does it cost? We don't care if it's gold pieces or dollars or rupees or whatever. It's just an integer value. It's a whole number value. And then an attack, which is also an integer. But you could have put floats or whatever. Typically don't sort bools, but maybe you could do a bool as well. I don't know. Yeah, so in Unity, what you need to do is on your class definition, in this case weapon, you need to extend the iComparable class. And then in angled brackets, you put in that weapon class. So you're going to take this weapon and compare it to another weapon. So this is going to tell the sort algorithm how to actually sort these objects. Because if you just pass an array of objects to your sort method, it's not going to know whether it's supposed to sort it on name, or if it's supposed to sort it on cost, or sort it on attack. So you actually have to implement this compare to method right here, and it's going to return an int just like that old stir comp in C. It's going to return -1, 0, or +1. Now, I think some languages just say it has to be greater than 0 or less than 0, but for all these examples, I'm just going to say it's -1, 0, or 1. So what you're going to do is, with that weapon that you're passing into this function, so that's the other weapon that you're comparing it to, the other weapon object, you're going to compare that to this weapon object. So I have this broken out into a switch statement right here. So I got all three sorting values broken into a switch statement. So if we want to compare by cost, all we do is set this type to 0. Then it's going to say, okay, if the cost of this weapon is greater than the cost of the weapon that's being passed in, then we're going to return a 1. Else, if the cost of this weapon is less than the cost of the weapon passing in, then we're going to return a -1. So I just assigned this to an iReturn integer variable right here. Then I just return that iReturn at the end. You could technically probably just do a return 1 right here, but I just want to keep things clean for this example. So yeah, that's all there is to it. And then when you do your array.sort, then it will sort based on that values. So If you want to sort by name, all you do is change that type to 1, which is actually what it shows in this slide right here. So if we're comparing by string or by name, then we're going, like that earlier slide that I had that had the different comparison methods, we're going to use string.compare with a capital C. Then we're going to pass in the name of this weapon and then the name of the weapon being passed in as a parameter. So that's going to be compare str name. I could have put this or self or whatever it is in C#. I don't know. I'd have to look it up. I think it's, I'm not sure if it's self or this. It's one of the two. Dot str name and then the str name of the weapon that's being passed in. Then we're just going to return that value because this compare value is already going to give you a 1, 0, or a -1. So you don't have to break that out into an if-then statement. And oh, by the way, in the previous comparison that I just talked about, I already have return set to 0 by default. So I don't have to have a specific else if or else for setting return value to 0. It's just, we're just going to assume it's equal by default. So for the objects, just going to comment out display stored strings. And so first of all, with weapons, we're going to actually have to build a list of weapons. And I got that in this parser, parse weapons. So I actually have that. This is like my quick and dirty way to define values. So I have weapons right here in a text file, comma separated. And then I have a parser class that's going to take that resource as a parameter. Then we're going to use as a text asset parameter. Then you just pull it in there. Then we're going to say, okay, get the value in that text asset and get the text value on that. Then that's going to be the contents of that file as a string. So then we can loop through that string, splitting using the .split command. So we're going to split on \n, which is the new line. So we're going to look at every line. And then within that line, we're going to split on the commas. So if we got 3 tokens in that line separated by commas, then we're going to assign those values to a new weapon. And then the weapon has a constructor which takes in a string as the first parameter, which is the name, an integer as the second parameter, which is an int, and then it's going to take another integer in as the third parameter, which is the third value. But you got to be careful because by default, all of these, when you parse these values out, they're all going to be strings. So you got to convert your strings to integers. And you do that by using int.parse with a capital P. And I think there's a way to throw a number format exception if it's not in the right number format, if you can't turn it into a number. But anyway, that's the parser. So here's our display weapons right here. So first of all, we're going to make a list of weapons by using that parser. Then we're going to call list weapons. Then we're just going to use that same .sort method right there. Yeah, we're just going to call .sort on it. And then we're going to display the weapon. So we're just going to print out the... Actually, we're going to split these out into 3 separate columns. So for every weapon, you're going to print out the name, the cost, and the attack. Let's see if that works. Nope. I didn't save. Save. Yeah, so here we go. So I actually took these names from the original Dragon Warrior, Dragon Quest. Now, I kind of changed up the cost and attack, and some of these may not make any sense, but I just did it to show that there's a difference in sorting by cost and then sorting by attack. Generally, as the cost goes up, the more attack value you're going to get. But maybe assuming one of these has magical powers or something, it has really low attack, but it has a high magic value, or it has some special property, which makes it expensive, but maybe have a low attack value at the same time. So now we're going to change. So if I was using this in a real game right here, weapon, I would probably have like a static value instead of having this as a local value for this function. I'd probably have this like a static or something. That way the user could change what they want to sort by in the game. Then you just change the static value right here. That way you're not having to manually go in and change it or have multiple comparative functions or anything like that. But there's multiple ways to handle that. So if we want to sort by cost, we just change that to a 0. Then run it. So now we got 100, 150, 180, 560, 640, 980. These are out of order, and these are out of order. But it's all ordered by cost. Then if we want to order by tack, just change that to a 2. Sort it. Now we got attack 8, 15, 15, 24, 35, 40. So that's sorting objects in Unity. That's all there is to it. So I'll put the code out there. Get it at knoxgamedesign.org. I'll link to it. And here's just another. This is what I just showed in Unity right here. The unsorted, sort by name, sort by cost, sort by attack. So the next game development environment we're going to look at, which is also pretty popular, I know, at least with Knox Game Design, is GameMaker. So in GameMaker, you basically use array underscore create to create a new array. If you don't know how large it's going to be, you can just pass in a 0. I think you can pass in a value if you know how big it's going to be, but I'm just going to assume we don't know how big it's going to be. Pass in a 0 as the size and let it automatically resize itself. Then you assign that to your array. So in most of these examples, I'm just going to call it my array. So we do my array gets array underscore create and pass in 0 as a parameter. Then we're going to set those same values that I used in the last example. 75, 59, 11, 35, 3, 10, and 10, 20, 21 as integers. We're going to assign those into the different array values. So for displaying this, some of these languages, they update every frame, and I don't want to run the sort on every frame. So what I'm going to do is create another array called myArraySorted. So myArraySorted, we're going to use the same array create. Then we're going to copy the same values from that first array using the array underscore copy function. We're going to pass in the first the sorted array, the array that we want the sorted values to be copied into, then 0, then the original array, and then the length of the original array. So I was going to copy all of those unsorted values in the original array to this new second array. And like I said, the only reason I'm doing this is so I can display both the unsorted array and the sorted array at the same time. Otherwise, if I was actually doing this in a game, I would just sort the original array and not worry about it, because I'm not worried about showing the unsorted array. So then after we have that new array copied over, all the values copied over, then we're going to call array underscore sort on that sorted array, and then we're going to pass true, and I can't remember what true. I think true either sorts it ascending or descending. I could be wrong about that. But yeah, so that's in the create method of our object. And then in the draw GUI begin, then we're going to set the draw color to white. We're going to draw some text, just say it's unsorted for the first one. Then we're going to loop through every value of that original unsorted array. And then we're just going to write those values down vertically. And then we're going to do the same thing for the sorted value. So you see the output right here on the right side. So unsorted, 75, 59, 11, 35, 3, 10, 10 and 20, 21. And then the sorted is 3, 10, 11, 35, 59, 75, and 20, 21. So that's all you had to do. Just call array sort for integers, and it sorts it for you. So here's GameMaker Studio. So I'm using GameMaker Studio 2. I'm not sure. There was a big leap from GameMaker 1 to GameMaker 2 or 1.4, whatever it was. So sorting in GameMaker 1.4 may have been different. Okay, here it is. So here's to create. And I have this on an object called sortIntArray. And here's the draw GUI begin. Now what we want to do. So for each of these objects, I drag one of these sorting demo objects into the room. So I think I can just disable. So I'm going to disable sort string and sort. So I just want to sort it in int array. So let's press play here. Yeah, so there it is. It's kind of hard to see, but yeah, unsorted, then sorted right there. So for the string array, we're going to go back to our workspace. And this is also in the slides. So GameMaker, opposed to Unity, is case sensitive. So capital letters, if you have something starting with capital letters, it's going to be sorted before things with lowercase letters. You can define a sort function to do a case insensitive sort. So here we have the create. We're going to do the same thing as we did with ints, but we're going to have our fruit right here, our fruit strings: orange, banana, grape, watermelon, lemon, and apple. Different cases for capitalization cases for each. We're going to create a sorted array. Then we're going to copy the unsorted items into the sorted array. Then we're going to call array sort and use that true. And so we're going to do two different things here. We're going to have two sorted arrays. We're going to have an array sorted with an insensitive, which is by default, and then by default it does a case sensitive sort, and then we're going to do a case insensitive sort. So to do the case insensitive sort, we're going to copy those values into an insensitive sorted array. And then what we're going to do is we're going to call array sort, pass in that array that's now unsorted, and then we're going to pass in the name of a function, which is case insensitive sort. So I have that function defined right here. So you just use the name of the function equals, and actually the keyword function. Then you pass in two parameters. We're going to have stir1 and stir2, which are two strings. Then we're just going to convert those two strings to uppercase by using string underscore upper. So if string underscore upper, and then you pass in the first string, is less than string underscore upper, and then pass in the second string, then we're going to return a -1. If the same thing is true but using a greater than symbol, then we're going to return a 1. Otherwise, we're just going to return 0. So that's all in our create method. And then in draw GUI begin, we're going to set the color to white. Then we're going to draw text unsorted, loop through all the values in the unsorted array, print those out, loop through all the values in the sorted array, the sorted case sensitive sort, loop through all those, print those out, then loop through all the values in the sorted insensitive sort, and print those out as well. So have that right here. Here's our function for doing the insensitive sort. And here's where we're setting up our two sorted arrays right here. And then we want to go back into the room and disable the sort in array and enable the sort string array object and run that. So yeah, we have our three columns. I know it's kind of hard to see. I don't have a magnifier program running right now. But yeah, so the first column we have orange, banana, grapes, watermelon, lemon, and apple for the unsorted. And then for the sorted, we're going to have the 4 that started with a capital letter. Banana, lemon, orange, and watermelon. Watermelons and lemon are actually all in capital letters. They're going to come before apple and grapes because both of those start with a lowercase letter. And then in the case insensitive sort, well, we have apple, banana, grape, lemon, orange, watermelon, where case doesn't matter. Just for kicks, let's see here. I'm going to change tree here to false. Run that. Yeah, so if you pass in, instead of a function, if you pass in false, and that's going to do a case sensitive sort descending. So we're going to have the two values that start with lowercase, grapes and apples at top. Then we're going to have watermelon W, then orange O, lemon L, then banana B. We're going to have B at the very end, capital B at the very end. That all goes back to that ASCII character value that I was talking about earlier. So here's how to sort objects in GameMaker. So an object, we're going to create the same array, array create 0. Then we're going to create multiple weapons. So we're going to have weapon. I bet this is going to get flagged because I'm mentioning weapon an awful lot. That's going to be unfortunate. I should have picked something, some other demo. I should have picked, I don't know. But yeah, we got weapon there. So we got a weapon. We created new objects using instance _ create layer. I think there's another way to create objects. I know and it's different in 1.4. So in GameMaker 2, you actually had to start passing in the layer ID. So we're just going to pass in 000, then the weapon, and then we're going to use weapon.stirName and pass in the name. For instance, here's a club. Weapon.iCost gets 640. Weapon.iAttack gets 24. Then we're going to assign that new weapon object into that array using myArray. Then square brackets 0 to weapon. Then the next instance we're going to assign it into 1, 2, and all the way down until we define them all. There's probably some neat way to load these in with a file in GameMaker. I just don't know how to do it, and I didn't feel like taking the time to figure out how to load a file in GameMaker, but I'm sure it can be done. So to sort, so as with the other object sort, by default, it's not going to know how to sort these. It's like, okay, you gave me a list of objects, but I don't know what to sort it by. So the first, we're going to sort by cost. So what we're going to do is create a function just like we did earlier. We're going to do weapon _ cost _ sort equals in the keyword function. Then we're going to pass in, just like we did with the string comparison, we're going to pass in the two weapons, weapon 1, weapon 2. Those are going to be your parameters. So you set those. So based on what you return from this function, that's going to determine how your objects are sorted. So we can do if weapon1.iCost is less than weapon2.iCost, return a -1 because it's less. Else if weapon1 is greater than weapon 2, then we're going to return a 1 because it's greater. Otherwise, we're just going to return 0. If it's not less than, it's not greater, then it's got to be equal, right? So then we're just going to use the same array _ sort. We're going to pass in the array of unsorted values, which is stored in myArray sorted 1. And then we're going to pass in that sort function, which is weapon _ cost _ sort. And I'll go ahead and say for attack, it's the same thing. We're just changing weapon 1 attack or weapon 1 cost to weapon 1.iAttack for all the different comparisons. So let me go ahead and run that. So we want to disable the string array, sort the weapon array, but then I need to go back here and look for my weapon array. So here's where I got defined all the different weapons, the 6 different weapons. And the different sort methods. So we're going to sort. So we got myArray sorted 1, myArray sorted 2, by cost, and attack. I don't have by string. That's interesting. Let's see what this does. Okay, so here it is unsorted in the first column, then sorted by cost in the second. So we got 100, 150, 180, 560, 640, and 980. Then in the third column, we're going to have sorted by attack, 100, 980, 180, 640, 560, and 150. And if we wanted to sort by name for an object, we just do the same. We just change out these values. For weapon 1 attack, we'd do weapon1.stirName. But you would use the string comparison instead of an int comparison, which is down here. So then we'd have to drop down and also do the case insensitive sort right there. So that's why I didn't show it in this example. So yeah, sorting objects by a string is a little bit more involved. But yeah, you can put it all in function and make it a little bit more manageable, I suppose. Oh yeah, so this is not an example in how to build beautiful UI. So this is solely on sorting. We can do a whole nother talk on how to make all this look pretty. So my objective is to show how to sort these things in the least amount of code, or least amount of code reasonable, without adding a bunch of yak in there to make it look pretty and everything. Because I found out with examples, if you start putting in a bunch of other crap in there to make it look pretty, then you kind of lose focus of what the example is trying to show. So that's GameMaker. The next one is I call it Godot. I've heard this was maybe based on a book. Sorting demo Godot? But it looks like Godot. Or Godot. I don't know. So one thing is, I kind of wish I had done this presentation in segments. Like, do the example, then talk about it. So now I'm having to go back and remember how I sorted these with Godot like a couple of weeks ago when I did this. So let's see here. So it's sorted an integer string. Let's see if I can bring this up. So I got a demo manager. Then I got a script. So yeah, I got this set up pretty simple right here. In demo manager, it's going to be like your main node. So a node is like a Unity game object or an Unreal actor. It's just an object. So in your root node, you're going to have this func ready, which is kind of like your start method, and you just change this value to whatever sort you want. So I'm going to change that to demo 0, which is the integer sort. Scene, save scene. So then based on which value you've selected, either 0, 1, 2, we're either going to do an integer sort, a string sort, or an object sort. So in Unity, you have GameObject.find, which I've always heard is a bad thing to do, but it sounds like in Godot they expect you to use getNode, and that's going to search all the nodes in your little tree over here. It's going to find the one called demo integer sort. Then we're going to call setup on that. So demo integer sort's right here. We're going to look at the code. So we're going to have a unsorted label and a sorted label. Then we're going to have, like all the other ones in the previous example, we're going to have an array called myArray of unsorted value. I don't know if I can make this bigger or not. Editor. Can I do control? Yeah, there we go. There we go. So I'm going to have myArray, which is going to be the unsorted array. Then we're going to have myArray sorted, which is a sorted array. We're not going to do anything in ready. We're going to call this setup method. So I'm going to get references to this unsorted label and sorted label. So this is kind of like the Unity UI text right here. So we're going to grab a hold of that, and then we're going to call sort integers and display arrays. So in sort integers, we're going to have myArray, then we're going to create this myArray. So we're just going to have myArray equals, and within square brackets, opposed to curly brackets in the other examples, we're going to have 75, 59, 11, 35, 3, 10, 20, 21, separated by commas. Then to copy that array into the sorted array, we're going to do myArray.duplicate. So that's kind of like the array copy in GameMaker. Then we're just going to call myArraySorted.sort, and that sorts it for you by integer. Pretty nice. And then we're going to display the arrays. So I'm going to build these strings right here, which basically just say unsorted. Then we're going to display all the values in that unsorted array, and then we're going to call set text on that label, and then pass in that unsorted string from that array. Then we're going to do the same thing for sorted. So, and that's all in this 2D interface. So you can see right here, I click right there, and that's the unsorted label. It's actually under a child of control. Then we're going to have a sorted label right there, which is also a child of control. So we're going to run this. Yeah, this is kind of hard to see, but you can see it right here. Unsorted 75, 59, 11, 35, 3, 10, 20, 21. Sorted 3, 10, 11, 35, 59, 75, 20, 21. So yeah, just call your array sort as long as it's a string. And also, see here, so yeah, my array sort, duplicate, that's just for display purposes. If I was using this in an actual game, I wouldn't duplicate the array. I would just call sort and then be done with it. So if you look at strings, okay, strings is a little bit different. So in Godot, like GameMaker, it does do a case-sensitive sort. You can use this method called sort custom, and then you pass in your array, your unsorted array, and then pass in your sort function to define your custom sort. And a little bit different than all the other ones, this custom function returns true if the value is less, or false if the value is greater. So this one doesn't use the -1, 0, 1. I should have made a table with like all the different comparisons between the game development environments. So this one's a little bit different. It uses true false instead of -1, 0, 1. But it's pretty simple. You just have func, sort, insensitive. You name it whatever you want to. Then pass in the two strings as parameters. So then I'm going to say if stir1, the first string parameter, dot 2 _ upper with parens. So that's how you turn that first string into uppercase. Is less than the second string, dot 2 upper with an underscore. Then we're going to return true. Otherwise, we're going to return false. We're going to display the arrays the same way, setting those arrays, building a string and setting those to the text value, text field using set _ text. But we're going to do this two different ways. That'll display. I don't think I showed it right there. So let's go back to Godot and go back to our demo manager. Look at the code. So in demo manager, we're going to set the demo to 1, which means we're going to see the demo string sort. Let's look at the demo string sort. So here we are building the array, my array, orange, banana, grapes, watermelon, lemon, apple. I guess that should have been grape. I don't know. Keep them the same. What plurality? I don't know. Is it one grape or multiple grapes? I don't know. Usually you don't just see one grape in a picture of fruit. Usually, sometimes you see one apple, you see one orange. Sometimes you see multiple bananas. And so that could be bananas. But I usually don't just see one grape. Usually you see the whole thing of grapes. Anyway, that's a bit of a tangent. So we're going to duplicate the array, then call my array sorted sort. So if you just call sort, that's going to do the case sensitive sort. Then I have another array called my array sort insensitive. So we're going to duplicate the original unsorted array, then do my array sorted insensitive dot sort _ custom. Then I forget what this first parameter is. I don't know if it doesn't have any like IntelliSense or hints or anything, but I think it just passes in cell. Oh, this means that this is the class or the object that has your sorting method, your comparison method. So since I declared the sorting method in this script, we're just going to use self. So you pass in, unlike many other languages, you pass in the name of your sort function as a string. That's very important. So if you just put sort insensitive without putting the double quotes around these, then I don't think it'll work. So where is our sort insensitive at? I don't see it. Oh yeah, right here it is. So we just have it defined. Yeah, I guess oh, there it is. I didn't have this lined up correctly. So yeah, so define your comparison method for two strings. We just have func, F-U-N-C space, and sort insensitive, which I think is what I just showed on the slide right there. Yeah. So yeah, that's the two upper comparison, return true, return false. So let's run this. So there we go. We have an unsorted column, orange, banana, grapes, watermelon, lemon, apple. Then we have a sorted column, banana, lemon, orange, watermelon, all in with an uppercase starting letter. Then lowercase apple and lowercase grapes. Then we have the sorted insensitive list, which is apple, banana, grapes, lemon, orange, watermelon, or case, doesn't matter. So I think a lot of people, probably a lot of beginner developers, will come in and create their string array and then call myArraySorted and then get the output and say, hey, why isn't this sorted? That's why. Because it's doing a case-sensitive sort where everything that begins with an uppercase character appears before everything that starts with a lowercase character. Yeah, I think I'm beating a dead horse, but that's a very important concept to know. And it all goes back to that ASCII value that I talked about earlier. So a uppercase O has a lower ASCII value than a lowercase, or an uppercase O has a lower ASCII value than a lowercase a. It sounds backwards. You would think that the lowercase a would have a lower value than an uppercase A. But it's not, and it probably goes all the way back to Fortran and the old teletypes when all they had was the uppercase characters. So they probably defined all the ASCII values based on the uppercase characters. Then they probably came in later and added all the lowercase letters, and then they had to assign numbers. So they didn't want to read. This is all my guess. I don't know. But I'm thinking they probably added those lowercase letters later, and then they didn't want to renumber the uppercase letters, so they just added those in later. So that's why lowercase letters appear after or have a higher ASCII value than an uppercase character. I could be wrong about that. Don't quote me on that, but that's my hypothesis. And it seems logical to me. I mean, I would have to meet like the creators of Fortran and see Kernighan and Ritchie and who was Bacchus Nauer, I think, created Fortran. I don't know if one thing that's always amazed me is like a lot of these guys, like Larry Wall, who created Perl, as of, well, I guess it's been 20 years since I did my undergrad, but at the time, a lot of these guys were still alive. So it would have been cool just to like call up Kernighan or Ritchie and say, hey, how's it going? I don't know if but a lot of them worked at educational institutions. They probably wouldn't answer your calls if you called them. But I think it's really cool that all these pioneers of computing are like still alive. It isn't ancient history or anything. I mean, these are actually like real people you could talk to and everything. So that would have been really cool to like have a class taught by one of those guys. Okay. So that's our string comparison in Godot or Godot. So now we want to sort objects. We want to sort objects in Godot. Checking my recording time, making sure everything is still functional so I don't lose an hour and a half of presentation here. So you can use sort custom, self, and that's what I just talked about. Then the function. So sorting objects is going to be very similar to our case insensitive search. We're going to pass in our array of objects as the first parameter, then we're going to pass in the name of the function, the sorting function, as our second parameter, as a string inside double quotes. Very important. So let's go back to our demo manager. Come on, demo manager. Oh, I got to click on the little scroll right there. Set the demo to 2, which is sorting objects. Let's look at our object sort right here, doing a lot of the same stuff, setting up the array. So I have a function, func, create weapons, which is going to set up our weapon array, which I just call it my array. So I just set up an empty my array right there. So setting up a custom node in Godot is somewhat aggravating. In Unity, it's pretty simple. You just create your object, and you create a script, and you drag your script onto that object. Then you create a prefab prefab folder, drag it into prefab, then you call instantiate, pass in your prefab, pass in a location, pass in your quaternion rotation, which I usually just use quaternion identity, or you can use like quaternion Euler. That's to talk for another time. In Godot, you create a node, and then similarly, you can create a script, which I have this weapon.gd script right here. That sounds wrong. They should have called it something else besides GD. But anyway, so I have 3 variables inside this weapon object: stir name, iCost, iAttack, all starting with var space. That declares it like an instance or object variable. And then I just have like a toString just so I could print this out easily. And then it just returns this string format right here with the 3 values right there. And by the way, when you're building that string, you got to make sure you do stir, then pass in an integer within parens to convert that to a string. Otherwise, if you try to concatenate a string and an int, I think it's right. That's one thing that's really annoying about some languages. So my first like big boy programming language was Java. And in Java, you can just like take a string and do plus and an integer, and then a plus, a float, and as long as it looks somewhat reasonable, it converted everything into strings for you. But in some of these languages, you have to explicitly convert your integers into strings whenever you're concatenating strings together. So concatenate just means putting a string together. You have the first part of the string, then you want to add something else, and that's concatenating strings. So in some of these languages, you have to do like a string, and then pass it in as a parameter to string or str, things like that. So I have a feeling that's something else that would hang up a lot of beginner developers. Like, hey, I just want to print out this object that has a name, an attack, and a cost. I just want to print it out. You just want to use either double dots or plus. Well, sometimes you got to explicitly convert those integers into strings. So yeah, this is like becoming a sorting / intro developer tricks and tips talk, basically. Okay, so the whole point of this is you create this weapon node within your structure, but then you have to actually go over here and do like save branch as scene, which makes no sense to me. And then it gets like saved as a TSCN under your resources. Then you can come up and in your main sorting thing right here, you can instantiate it by doing like create a new variable. I have var space weapon scene because it's called the scene for some reason. And then you assign it load open paren, and inside double quotes, res, I guess that means resources, colon, // then the name of like your object, which is a scene. Very hokey to me. I think that's one thing in Godot they could really improve upon, because that just doesn't seem very intuitive for instantiating an object or a node or whatever. But then after you have that, then you can just say weapon, which I have a var weapon, equals, then take that weapon scene that you just loaded, and then you do .instance. So that will create a new instance of that node. Then you can just assign directly. They're kind of like public instance variables. You can assign to the name. Here I have club, assign to the cost, 640, and then attack 24. Then here I use myArray.append weapon. That's the easiest way I found to add objects to that array. So I'm going to do that 6 times for each of the different weapon types. I'm using the same data that I used for the other examples. And then after we create our weapons, and we're going to sort our weapons. So sort weapons, we're going to create a sorted array. So we're going to use myArray.duplicate, kind of like we did with the other ones. And here I have the 3 methods right here. So I have the first 2 commented out, but I got the 3 different ways to sort. All 3 of these are going to use myArray sorted.sort custom. And then we're going to pass in self, because the sorting function is defined in this script. Then we're going to pass in sort weapon name. So sort weapon name is going to take two, you define it down here, func sort weapon name. It's going to take in two parameters, weapon 1, weapon 2. So we're going to say if weapon 1 dot stir name dot 2 upper is less than weapon 2 stir name 2 upper, then we're going to return true. Otherwise, we're going to return false, just like all the other string comparisons. So let's run that. So yeah, here we have it. Unsorted, club, bamboo pole, hand axe, blah, blah, blah. Then sorted, we're going to have bamboo pole, broadsword. You have your B's and your C's and your F and your H. Flame sword, hand axe. So we're going to comment that one out. We're going to do my array sorted, sort custom self, sort weapon cost, or here's our weapon cost. Basically doing the same thing. We're just taking the first weapon, getting that cost instance variable, checking to see if it's less than the second weapon cost. If it is, we're going to return true. Otherwise, we're going to return false. Run that. So you can see in our sorted column now, we got 100, 150, 180, 560, 640, 980. And then the third way of sorting these, we're going to sort by attack. So in our sorted column now, we got 8, 15, 15, 24, 35, 40. Now, there's like an edge case right here. We got two weapons with the same attack. So if you really wanted to, you could define... it'd be very difficult, but you can define a second method for sorting. Like right here, we have both hand axe and copper sword that have an attack of 15, but hand axe appears before copper sword, even though they both have the same attack. So if you really wanted to, you could come in like weapon attack. Actually, you couldn't, because there's no equal case right here. In other languages, you could say if weapon 1 attack equals weapon 2 attack, then you could say if weapon 1 dot stir name is less than weapon 2 dot stir name. I don't think there's a way to specify a secondary search parameter if they're both equal in Godot. That's very interesting. That's one downside of having only return true or false. I don't know how you'd get around that in Godot, but usually it doesn't matter. Usually you just want to sort by attack and you don't care if the second sort parameter. But that could come in, that could be useful. Like if you had a type, like if you wanted to have like bows and arrows as one type, and you'd have it defined as an energy, you'd have like bows and arrows, and you'd have swords, and they have pole arms or whatever, and then whatever other weapon type. You may want to sort first by weapon type, and then sort by weapon name or weapon attack or something. So I don't know how you would handle that in Godot. You could actually handle that in GameMaker and Unity and the other ones. I don't know how you would do that. So yeah, that's all three of these sort types in Godot. Yeah, so here's all the Godot functions right here that I just showed. So the next environment we're going to look at is Unreal Engine. So I spent a lot of time, probably more time than I should have, figuring out how to sort in Unreal. And I also did C++. So this is my first time doing real C++ in Unreal. All the other two or three games that I've done in Unreal have all been using Blueprint. So I was like, okay, it's time that I break down and learn how to do C++ in Unreal Engine, because I don't think, maybe, I don't know, I didn't look into it, but I don't think it'd be very easy to sort objects in Unreal using blueprints. Maybe it is, I don't know, I didn't look into it. So, okay, so one good thing about Unreal now, I found out, and I might have made this link a little bit earlier before I started doing this presentation, but now I found out how to actually run Unreal Engine directly from the desktop without running the stupid frickin' Epic Games launcher. I hate the Epic Game launcher. It's like, I don't want to see stupid Fortnite, and I don't want to see all the other stupid Epic games. I just want to run Unreal Engine. So that was one of my gripes, and now I can just run Unreal Engine, so I'm much happier now. So here's my other complaint. I didn't know about this before. one real complaint I have about Unreal. I think I know why they did this. So instead of being able to just like create a C++ string, a standard STL C++ string, you can't. As far as I know, you can't easily create a string. You have to use the custom F string, capital F, capital S, string in Unreal. Also, you can't use the standard C++ vector. It would have been so nice if we could just did like using std and just use the vector. No, you can't. You got to use a T array, which I guess is table array or capital T, capital A, everything else underscore. And it kind of works like a C# list. You have T array, then in angled brackets, int or whatever data type. Is that? Yeah, int is an atomic data type, or at least that's what we used to call it. I don't think a string is, because a string is a combination of integers. But I guess you could put F string in there. It's like a template, a template type right there. And you do T array int in angled brackets for an int T array, and I'm just going to call it my array equals, and I'm going to use the same values: 75, 59, 11, 35, 3, 10, 20, 21, close squiggly bracket, semicolon. So we're going to display string unsorted, display array. So display string is not a standard Unity C++ thing. It is a custom method, which is down here in this. It's pretty hard to see, but in this lower right hand corner, and I'll put the slides out there for anybody that needs this to be bigger. I think it may look okay if you like run this in full screen. I don't know. But I have this custom display string, which takes an F string as a parameter, and then it calls this G-engine pointer add on-screen debug message, open paren, -1, 60.of, color, white, then your string, str, then false, f vector 2d, which is the location, I think. Or no. I don't know what that, because it pushes up. The point is, in Unity, just call debug log, and it does the same thing, but this is like this horrible looking. What I would do, I just have this an overloaded method and have like a version of this method with two parameters, like the string and the location. Be done with it. But it does push it up, so I don't know if that's really a location or not. I'm not sure. Oh, f vector 2d is the size. So I remember when I originally ran this, the text was way itty bitty itty tiny, so I used that f vector 2d to make it a little bit bigger. So I made my custom display string. And similarly, I created a display array function which leaps through every value in that T array and writes out a string, comma, separated with that. So, but the actual sorting of the array is pretty simple. You just do myArray.sort, capital S sort, with no parameters, and then display that sorted array, and there it is. And Unreal is actually really slow to. So here's the sorting demo. Now the other aggravating thing about Unreal is that the default scene has like these chairs and a table. So you always got to delete those stupid chairs and table. And then the lighting is baked in. So you always have to go back in and rebuild that. So we'll take the lighting out. One thing that really confuses me is this compile option in Unreal right here. So sometimes, oh shoot, I already forgot how to bring up the code. I think I just have this demo manager right here. So everything in Unreal is an actor instead of a game object or a node. So let's open demo manager. One nice thing is it still opens everything up in Visual Studio. So if you're already familiar with Visual Studio for Unity, you're using the same editor right here, which is kind of nice. But I've had more luck going in and using, where is it? Build solution instead of compile. Sometimes it's really weird. You can press compile and your changes won't be reflected. Then you'll run it again a few seconds later. Then then it will work. And I'm like, why did it work that time? I don't know. So this is our header. So this is the other real gripe I have about C++. It's only a single pass compiler, so you always have to have your stupid .h header file right here. And you got to define all your methods and variables, instance variables in your header file. And you got to spend all this time trying to balance, keep everything in the stupid header file balanced with what's in your CPP file. It's like, why can't I just make my CPP file, then have the header file automatically generated? If they don't want to have a double pass compiler like Java and C#, but I guess I can see because C++ came before Java and C#, they didn't know how to write a double pass compiler, so they just said, okay, leave it up to the developer to make a .h file with all the function definitions. Oh, and by the way, sometimes, like when I was doing classes in C++ and in Unreal, you actually have to define the class in your .h file as well, the class that you want to use. If I included the .h file for the class that I was using, then it would throw errors, like, oh, you can't define it here. So I want to go ahead and throw that in before I forgot about it, because that threw me for a loop for a while. So here's so we're going to call sort. So like the other examples, I got a demo manager, : begin play. So begin play is kind of like initialize or start or whatever. So I got three methods: sort integer, sort string, sort objects. I'm going to leave sort strings and sort objects commented out. So this is what I was just showing on the slide right here. So let's go ahead and build solution right there. Let's go ahead and build it in Visual Studio. The nice thing about building this in Visual Studio is if you have errors, you're going to see a lot more details about the errors in Visual Studio. Wait for this to finish. If you build it using compile, then you get a lot less information. So if you're trying to figure out what line of code the error occurred on, sometimes you don't see that in the Unreal editor using compile. Okay, it's finally finished compiling. I don't know how that got changed to Japanese. Okay, so you can also hit compile right there. Maybe this is a little bit fast. It is faster if you've already compiled and you hit compile again. I guess it builds those internal objects and just links them together. So we're just going to press play. So here we go. Unsorted, 75, 59, 11, 35, 3, 10, 20, 21. Sorted, 3, 10, 11, 35, 59, 75, 21. And oh, by the way, by default, when you use that method to display the debug, where is it at? By default, this add on-screen debug message, if you pass true as this parameter after your string, then it's going to display the newest first, and then it's going to push everything down. So when you have your output, you're going to have to read down to up. But if you pass in false, then you can read it top to bottom. Otherwise, this is going to be backwards if you press true, which I think is default. So then sorting strings in Unreal. So we're going to have another T array. And like I said earlier, you can use that F string as the template or whatever right there in angle brackets. My array gets, then we're going to do the same: orange, banana, grape, watermelon, lemon, apple. Then we're going to say display string unsorted, display that array. Then we'll say display sorted. Then we're going to just use my array.sort, display array. So this does a case insensitive sort by default. So you don't have to worry about converting everything to uppercase or lowercase or anything, or doing any custom methods to sort the array. Overload display. Ooh, that's a typo. Display T array of F string. Oh, so I have multiple implementations of display array. So I have 3 display array methods, but I'm overloading them. So overloading them means that you're going to have the same function definition or same method definition, but you're going to pass different parameters. Then based on which parameters you pass, it will pick which method of those 3 that it's going to call. So if I pass in display array and I pass in a T array of weapons, then it's going to weapon objects, then it's going to call this one. If I pass in a T array of F strings, then it's going to call this one. And then if I pass in a T array events, then it's going to call that one. This one right here. And this is important because it varies ever so slightly. So when we're building this output string to display the array, like I said, with Godot and all the other ones, you have to convert those integer values to strings yourself. So in C++, or in this kooky version of C++, this Unreal version of C++, you use fstring : from int, then pass in the integer value, which is that array index right there. But if we're passing in an array of f strings, they're already strings, so we don't have to do that. That was weird. Okay. And I'll talk about objects a little bit later. So, let's go back. Comment out, sort integers, sort strings. So here's our sort strings. Pretty simple, just my array sort, build. Yeah, so that was actually pretty fast right there. It's weird how sometimes it can take minutes to compile and sometimes it'll take seconds. Doubly compile. So we can see here unsorted orange, banana, grapes, watermelon, lemon, apple. Sorted apple, banana, grapes, lemon, orange, watermelon. So we don't, yeah, case insensitive sort, which is kind of nice. Because I think by default, 99.9% of the people or developers who have an array of strings, when they want to sort it, they want to sort it insensitive. I don't know what case you would want to sort sensitive, case sensitive. Okay, so we've sorted strings and sorted. Take that out. Sorted strings and integers. Now we want to sort objects. So I created an object called weapon. It took me a little while to figure out the correct way to define a custom class. So you want to create a custom class which inherits from actor. So you just go here, file, new C++. You want to use this one. Because I was like trying to make a new class down here or over here, but you want to use it in your drop-down menu. Then you just say pick actor right there, and you can inherit from actor. Then it's going to actually ask you about public or private. I think I just used public. So that'll create a weapon. I don't even think it appears down here, but it will appear in your editor and your public folder. So it's going to put your .h file in public, then it's going to put your class in private. So it's a pretty simple class. So this is one weird thing about Unreal, is whatever you name your class, if it inherits from actor, it's kind of like doing the Hungarian notation for you. It's going to put a capital A before your class. So it's going to do a weapon, : a weapon, which is kind of weird. But it is kind of nice to go ahead and defines all this .h header stuff here for you. So if we look at the weapon header, here's where we define in this public section all the instance variables. So first of all, we're going to have the constructor, capital A, capital W, weapon, a weapon constructor. Then we're going to have a string for the name, string name. Then we're going to have an int for the cost, and we're going to have an int for the attack. I think some people do an int 32. I mean, maybe that's more technically correct. I don't know. I just use ints. So that's all there is to weapon. I mean, I didn't change anything in the actual CPP file. I just defined these instance variables right there. Then in our demo manager, let's go back, sort objects. Sort objects. So I'm going to create a T-array. I'm not sure if this is, I think this is the right way to do it. I mean, it works for me. So I created a T-array of pointers, a weapon pointers. And then I call that myArray. So then I'm going to have a function. I created a function called createWeapon. I pass in a string, and two integer values, the cost and attack. Now, originally I had all this defined up here. And I was like, okay, I'm rewriting too much code. I need to put this in a function. So I created this createWeapon function. So createWeapon, like I said, it takes a string, f string, an int, and two ints, cost and attack. So we're going to create a new pointer to a weapon. And you got to do this f actor spawn parameters yak. It didn't even use it. I don't know. So then we take our weapon and then we use get world spawn actor. Then we use the angled brackets and pass in the type, which is a weapon. And then we pass in the location as an f vector. It's kind of like using instantiate in Unity. So we pass in the location, we pass in the rotation, f rotator, then that spawn info. I don't even know what spawn info does. I'm not an expert Unreal C++ developer, so I just learned enough to learn how to sort objects. So we're going to take weapon, use that arrow dash greater than symbol, kind of like in C. Take the stir name, then we're going to assign that to the first parameter. We're going to assign the first parameter to the stir name, take the second parameter, assign it to cost, iCost, and take the third parameter and assign it to iAttack. Then we're going to return that weapon. So from what I understand, you have, like in the memory of your program, you have the stack, which grows as you call function, then you have the heap at the top. So whenever you allocate this weapon right here, it's going to create it on the heap. So whenever the stack goes away, you're still going to have the reference in memory to this weapon object. And since you're returning it, then you're still going to have the pointer to it, but it's just going to, you're going to point it, you're going to add that pointer to this new weapon to your myArray using myArray.add. So that's what you have here, pointers to a weapons using that star right there. So yeah, that's how I build all of the objects that are in the T-array. Power goes out right now. I'm going to be crying. I'm going to stop and start this again. So as a slight aside, I've had recordings that are recorded in MP4 format using OBS, and I just saw the lights flicker a little bit, and there's been rain lately, so if you're in the middle of recording an MP4 and it doesn't finalize, then you lose everything. Now, when we're doing the meetings, then I'd use the TS format, which doesn't need to be finalized. But I figure since this is just me, then I'll just go ahead and do the MP4. But I still get nervous during rainstorms and everything because I don't want to lose an hour and a half of a talk. So here, what we're going to do is to sort by the different object properties. We're going to use, I have this on the slide right here. We're going to use algo : sort by. Then as the first parameter, we're going to pass in myArray. Then then we're going to pass in this ampersand, this reference to my class, my variable. So in this case, it's going to be ampersand a weapon : stir name. Now, that's why I say I'm not a fan of C++ because a lot of this still doesn't make sense to me. I mean, I started learning C++ back in like 1999, and a lot of this still doesn't make sense to me. I guess if C++ was my first language, I still don't think I'd understand it. I'd rather just do C or C# or Java. A lot of this stuff in C++ just doesn't make sense. Yeah, so based on what we want to sort by, we're just going to change that variable to be either stir name, iCost, or iAttack. And you can also pass in a third parameter, And this is stuff that doesn't make sense to me either. You can pass in a third parameter to your algo sort by, which is like T greater with capital T and G, and then an empty angled brackets, then empty parens, and that will sort reverse or back. That makes I don't understand. It's kind of, I understand it in like GameMaker and Godot, but I don't understand this notation with the empty brackets and everything. It just, I don't know what that's doing, but I understand the concept. So I understand it's like, well, you can pass in T less or whatever right there, then that will sort it in order. So I spent a lot of time trying to, I read something online, is like, well, when you sort using, where is it? When you sort by using tarray.sort, then it's going to use the less than operator to determine what order things go in. So I spent like hours trying to override the less than operator for my custom weapon class, and I tried to like 10 different ways, and I could not get it to work correctly. In some cases, I would compile it, and it would sort one way on one run, then it would sort a different way on another run, using the exact same build. And I think I read something like sort it, sometimes it's, I don't know, what's the word? Yeah, so sometimes it just doesn't work the way you expected it to. But I found another post that said, okay, yeah, just use algo sort by. That'll make your life so much easier. So that's the way I recommend. It's just a little bit weird with that ampersand a weapon : stir. I guess that's getting the stirred name, but that would be on the class, and you're getting a reference to this on the class. I don't understand. I could understand like getting that parameter on the instance of that class, but not the class itself. So I'm not sure what it's doing there. But it works. Yeah, so I'll put it right here. myArray.sort may be possible with overloading the less than operator. I couldn't get it to work. So anybody out there wants to try, let me know if you get it to work, because I couldn't get it to work. So yeah, remember in your... This is probably, if you've done a lot of C++, I mean, this is probably common sense. But this is something that took me a few minutes to figure out. You got to include, and I know in my other SDL-like games I've done this, I just wasn't thinking about doing it here. You got to include your weapon in your weapon.h in your file right there. And as I said earlier, you also have to define class weapon here. That's stuff with C++ that drives me nuts. It's like, why? Why do you have to define? I know it's because it doesn't know what it is yet, so you have to define that prototype, or they call it something else. Forward declaration. So, I don't know. So anyway, we'll sort by stir name, save. Go back here. Oh, I need to recompile. Okay, so let's just try recompiling it here. See what it does. So, okay, compiling, see if it works. I think if you have good code, then pressing compile here probably does the same thing. But if you have issues with your code, pressing compile here doesn't help you. Let's see if it works. Yeah, there we go. So unsorted, club, bamboo pole, hand axe, blah, blah, blah. Sorted, bamboo pole B, before broadsword, BR, club, CL, before copper sword, CO. So that worked. So if we go in here, uncomment out, sort by cost, comment out, sort by name, go here, press compile. I do like the little beep that it does when it's finished there. I just wish the beeps were a little bit different. Because whenever I press compile, I think it's already done, because it's the same blip and bleep. So here we have sorted 100, 150, 640. Oh, that's not sorted right there. That did not work. Yeah, this is the same this is still sorted by name when I did a compile. But I bet... Oh, let's just try it again and see if it works. Play. Okay, same thing. Now let's go here, build, and I did save because there isn't a star there. Build solution. Succeeded. Let's try running it now. Okay, now it's sorted by cost. 100, 150, 180, 560, 640. So pressing compile in Unreal did not compile it, or for whatever reason, it didn't look at the demo manager class and see that it had been changed. Because I did save it after I made the change. Let's try it again. I'm going to save. Compile. I bet it's still sorted by cost. Maybe not. Well, that time it did sort it. 8, 15, 15, 24, 35. So yeah, it's things like that that drive me up the wall. Maybe I missed. I'll have to watch this back later and see if I missed something there. Maybe I didn't save it. I don't know. Okay, so this is basically just showing what I just did. Sort by name, sort by cost, sort by tag. Okay, so this is the last one that I did. I worked on this one today, and this one's quirky. Some things are easy, some things are a little bit more difficult. So, sorting in Pico 8. Let me go ahead and start Pico 8. Close that. Pico 8. Now, if I can remember what I called it. Can I just type in load? Will this bring up... Yeah, it doesn't bring up a sort ints. Sort ints. I got it. Okay. So, Pico 8 also has what they call tables instead of arrays. But it's basically an array. There's no built-in method for any type of sorting in Pico 8. I thought that was kind of disappointing. I would have thought if you had an array, if they would have some sort function for sorting that array. So there's no built-in function for sorting in Pico 8. And this may be helpful for developers that use Pico 8 and want to know how to sort an array. So what you have to do is you create a function. You just call it function. And I called it sort. It can be whatever you want to call it. And you pass in parent. And as the parameter, you pass in your table. You can call it whatever you want to. I call it T here. And then I found a really nice piece of code. I'll admit I used that code and tweaked it slightly for this example. And I put a reference at the very end of that code if you want to go see it. It's pretty simple code. But it's an insertion sort. One of the ones that I showed earlier. So what we're going to do is for I gets 1, and that little hashtag T, that returns the length of your table, your array. Then we're going to say do, then we're going to use this J parameter, we're going to set J to I. Then while J is greater than 1 and the value of J minus 1 in the table, the index of J minus 1 in the table is greater than the current J index of the table, then we're going to swap those two values. So I think that's what it's doing right here. TJ, comma, TJ minus 1 gets TJ minus 1, comma, TJ. That's just going to take those two values and swap them. So it's just going to keep swapping down the row until that value is the lowest that it's supposed to be. So if you have a 5 and an 8 and a 9 and a 2, then it's going to swap the 5 and then 8, then the 5 and the 9. Then it's going to say 5 and 2. No, I'm already bigger than 2. I don't need to swap again. Then on the next round, it's going to look at the 8 and 5. And the next pass through, it's just going to pass through everyone in there. Then we're going to do this basically J minus right here. J gets J minus 1. So we're going to go through. That's what it's doing, going down through all those values, swapping them all. Then once we break out that loop, then we're going to look at the next index. We're going to keep incrementing that value right there. You know, J gets I. So to create a table in Pico 8, it's just my table equals, then we're going to use curly brackets, 75, 59, 11, 35, 3, 10, 20, 21, close curly bracket. I don't know if the semicolon's needed. I figure it probably would have crashed right there. We can try it out. But we're going to print unsorted. Then I have this method called print table that prints out all those values in the table. Then we're going to put a new line that's sorted. Then I'm going to call my custom sort function. Like I said, this is going to be whatever you want to call it. Then pass in that table. Then we're going to print the table after it's been sorted. So then when we run it, it's going to say unsorted 75, 59, 11, 35, 3, 10, 20, 21. Then sorted 3, 10, 11, 35, 59, 75, 20, 21. But I am curious. So that's what this is right here. I think it is important to define your functions at the top if you don't have this in a function right here. Otherwise, it's going to say print table doesn't exist. Print table function doesn't exist, or sort does not exist. But I can press escape, type run. That's what you see right there. But my question was, do I have to put the semicolon at the end of that? I don't think so. Let's see. Nope. But there's things about Pico 8 I don't understand. It's like, when is a new line allowable? It's like, can I put in a new line right there? See, that works. But since there's no like terminator symbol like a semicolon, I'm not sure exactly where you can break things. Like, can I do J equals I? I guess that works. I guess it's smart enough to know, to fix things like that. I don't know. So that's sorting ints in Pico 8. Lua. Well, it's either a Lua or a Lua clone or a Lua-like language. I don't think it's like standard Lua, but it's close enough. It uses 1 as a start index for tables, so it's pretty darn close to Lua. Okay, here's sorting the string table. So, the one interesting thing about Pico 8 is there's no concept of uppercase characters and lowercase characters, so we don't have to worry about case-insensitive sorts. It just sorts the string, and you don't know if it's uppercase or lowercase. There's just one case of characters. So here we have my table gets orange, banana, grapes, watermelon, lemon, apple. We're going to print unsorted, print the unsorted table, then print the sorted table. We're going to use the same exact sorting method that we've defined for the integers. No changes at all are needed because we don't have to worry about uppercase and lowercase characters or anything. Then we're going to print that table. So what do we have here? It's going to Pico 8. We have orange, banana, grapes, watermelon, lemon. I did this earlier. I just don't know why I didn't save. Run. Yeah, there we go. So we got unsorted orange, banana, grapes, watermelon, lemon, apple. Sorted apple, banana, grapes, lemon, orange, watermelon. So with Pico 8, what you can do is save sort strings. Maybe it's so in Pico 8 you can do folder, and we'll show you the folders. So see if it's in here. Nope, still ints. So I want to save sort strings, overwrite yes. So now if I look at sort strings, then it has the strings in here. So then I can just like copy these into whatever folder that I want. You can actually go into the Pico 8 configuration file and define where you want to set. They call them carts. The P8 file or carts. You can actually define where you want to save your carts or your save files if you go into the Pico 8 configuration. But like every time I set up a computer or something, I got to go back in there and reset that. So sometimes I guess it's just easier just to type folder than copy them because that's always going to work. So F5. So we're sorting an object table. So we're going to have the same my table, but we're just going to define it as an empty. I guess it doesn't need the semicolon. Just define it as an empty table. Then we're going to create a weapon. And then it's kind of like we're just going to pass in the instance variable name. I guess it's kind of like a hash. I guess it's a hash table. Name gets club, comma, cost gets 640, attack gets 24. So that's how we're defining our object. And then we're going to use the add keyword. So add to my table that weapon. So then we're just going to define, and they can all be the same name because we're creating a new pointer each time. So every time we create that weapon, then we're going to add it to my table. So we still have references to all those weapons. So it works out pretty good. So let's go in here. Oh, and by the way, if we're sorting objects, then we do have to slightly change the sort function, our custom sort function. So where we had T with the square bracket, J minus 1, we want to add dot name or dot whatever we're sorting on. And then I think that's less than. If it's less than T square bracket J dot name. Or this could be dot cost or dot attack. So let's do load sort objects. And yeah, you can see right here. So I had it set to attack. And also changed the print table method, which I actually show in the slide right here. So to print out that object, it's a little bit different. We got to do this v.name, and the concatenation operator is dot dot. So we're going to do v.name dot dot, comma dot dot, v.cost dot dot, comma dot dot, v.attack. So like I said, this is not an exercise in making pretty interfaces. This is only to show the objects that have been sorted. So if you're really doing this in game, you'd want to make this pretty right here, or have it print out in nice pretty columns and things like that, because getting things to print in columns, that's a whole nother talk. That can be quite painful sometimes. So run. So I guess I should have started out with the name, but that's attack right there. So unsorted club, bamboo pole. So we got 24, 8, 15, 40, 35, 15. Then sorted by attack. Then we got the bamboo pole 8, hand axe 15, copper sword 15, club 24, flame sword 35, broadsword 40. And again, you could add additional code to have a second sort parameter, since the hand axe and the copper sword both have an attack by 15. It's just, you can't determine which one's going to appear first when they're the same value. So let's go back and press escape. Go back here and let's do name. I don't know if you could like pass in. Yeah, you really couldn't pass this in as a parameter, but you could have like a select statement or a switch or something right there to say, hey, which one do I want to sort by? Oh yeah, and also change the title there, or the display. So we're going to say sorted by name, run. So yeah, now we have sorted bamboo pole, broadsword, club, copper sword, CL comes before CO, bamboo pole is the first one, BA comes before broadsword, BR, then finally at the end we have flame sword and hand axe. And so if we want to sort by cost, then we just change the cost right here. So yeah, if I didn't mention earlier, this is an insertion sort. I saw some other examples of people doing heap sorts and everything, but those seem to be long and, I don't know, not pretty. So the insertion sort for a short set of values seems to work pretty darn good. So yeah, sorted by cost 100, 150, 180, 560, 640, 980. So that is basically it. So what did we do? We did 5, 1, 2, 3, 4, 5. We did 6 different game development. How to sort ints, strings, and objects in 6 different game development environments. So here's some references if you want. Oh, I just put the link to the, for that sound of sorting program, I just put the link to a video, but there's actually a website, and I think they go into a little bit more detail. You can actually download the source code for this too, which is pretty cool. But yeah, it's panthema.net. So I'll just go ahead and throw that in there as well. Sound of sorting. Yeah, here's some information if you want to learn more about Big Theta and Big O and everything. When I was doing the C#, was it C#? Yeah, when I was doing the C# with the I comparable, there's a link to the page from Microsoft for the C# on how to, all the information about I comparable. Here's information about GameMaker array sort. So for basically all these Godot array, here's the array class and the sorting. Unreal Engine T array sort from the Unreal site, and Pico 8 table sorting from Lexel Awful right there. Okay, so that was a lot, and appreciate everyone who sat through all of that. When I post this online, hopefully I can do like the different sections. So if somebody just wants to like know how to sort differently in C++ for Unreal, they can jump directly there and not have to find or scrub through the whole video or anything. But yeah, it was a very interesting exercise. I like doing common problems in different languages, in different environments. So I didn't know if it would be possible to display or prove that it could be these objects could be sorted on all those different environments. But yeah, I guess so. And I didn't do like SDL or, I mean, I think Monogame, since it's C++, it would be very similar to it'd be very similar to Unity. I didn't do like Smalltalk or Java or any of that, but I'm sure they're fairly similar. I didn't do Construct 2. I can't think of it. I didn't do JavaScript, but I think all the other ones should be pretty similar to that. So anyway, as always, check out, let me go back. Check out knoxgamedesign.org for all the latest information about our group. Got all the past videos and presentation slides and example code and what people have been working on in the Discord group. You can like join us in Discord just by clicking Discord right there. Go to the podcast, and I think I updated the directory a little bit, added some more information. One thing that I'm trying to figure out is like how to do the handles for people, because now I took out the links and now I'm adding people's Discord handles. So I'm thinking is like, well, should I go out and delete all the old handles and just only have Discord handles, or should I put like Discord or Gab or whatever, MeWe or whatever handle? Because like mine, I think it's an old handle, so mine should really be like Levi D. Smith or LD Smith and not LD Smith 42. I don't know. But anyway, check that out. Oh, yeah, and I made a slight update to the Gomenisai game, which is like, sorry, I added some additional models like these nuts and buttons and these jacks, which it was a pretty interesting exercise to model those in Blender, but I think they came out pretty good. I used an array for the jacks, a Blender array modifier, so I just had to model the 4 arms around the side, and then I used an array modifier to space those out 90 degrees apart. Then I did the top and bottom, which don't have the little balls at the end. The buttons were pretty easy. I just used a difference modifier, a Boolean difference modifier to make the little holes in the buttons, and I'd already had the pawns in there, and the nuts were pretty easy too. I think the nuts I just started out with a circle with only 6 sides. So if you need to make a hexagon in Blender, just make a circle with only 6 points, and that will make a hexagon for you. Then I just use the Boolean modifier to put a cylinder in there and drill the cylinder out. But it's almost done. I need to add music. I'm kind of in a slump on this one. I need to add music and add a couple of things like a hand over this. But the gameplay's done, and it seems solid. I actually put an entry on my page for it. I just haven't put links to actually play the game yet. But hopefully I'll have that out soon. Hopefully by the time I post this, or not long after, I'll have the playable version of this online. It's not going to have leaderboards. I couldn't really figure out a way to have leaderboards for this because you're playing against AI. I mean, it's like maybe completion time or something. I don't know. The thing is, there's so many options to this. You can modify the number of players and things like that. So it's hard to have a consistent baseline on how people compete against each other. So anyway, that's going to wrap it up for Knoxville Game Design, or Knox Game Design for March 2021. Hopefully I'll be back in a month. And yeah, Ludum Dare is coming up, I think, in April. I'm not sure if we're going to have a get-together. Well, I think it's just going to be a small group. If anybody, I don't know. Times are weird, so I'm just going to keep plugging along and keep doing a presentation every month as long as I can, and say, hey, if anybody wants to get together, it's cool with it, and that's cool with me. Or if nobody wants to do Ludum Dare, that's cool too. But anyway, appreciate everyone out there listening and watching.